Carbohydrates. Introduction. Most abundant organic biomolecule in nature. Principal class of energy yielding nutrients. Consists of carbon, oxygen and hydrogen. Biomolecule functions of carbohydrates. Energy source. Glucose is the major biological fuel. Energy storage. Glycogen, muscle, liver. Building blocks of RNA and DNA. Act as cell membrane component. Dietary fiber. Lignin, cellulose. Structural component of many organisms. Classification of carbohydrates. Monosaccharides, disaccharides, oligosaccharides, polysaccharides. Monosaccharides. Simplest carbohydrate unit. Disaccharide. 2 monosaccharides units. Oligosaccharide. 3 to 10 monosaccharide units. Polysaccharides. More than 10 monosaccharides units. Monosaccharide. Simplest unit of carbohydrates. Example, glucose, fructose, galactose. Monosaccharide can be classified by the number of carbon atoms in the molecule, functional group present in the molecule. Classification of monosaccharides. The monosaccharides can be classified based on the number of carbon atoms in the molecules. 3 carbons. Trioses. Example, glyceraldehydes. 4 carbons. Tetroses. Example, erythrols. 5 carbons. Pentoses. Example, ribose. 6 carbons. Hexoses. Example, glucose. 7 carbons. Heptoses. Example, sedioheptulose. 9 carbons. Nonoses. Example, neuraminic acid. Classification of monosaccharides based on the functional group. Aldoses, ketoses. Aldoses. Functional group is a aldehyde, CHO. Ketoses. Functional group is a ketone, CO. Aldoses. Suffix -ose. Ketoses. Suffix -ulose. Aldoses. Example, glucose, lactose. Ketoses. Example, cellulose, ribulose. Isomerism. Compounds that have the same chemical formula but have different structure and configurations. Carbohydrates have different isomers due to presence of asymmetric carbons or chiral carbons. 1. D and L isomers. 2. Epimers. 3. Aldose and ketose isomerism. 4. Pyranose and furanose ring structures. 5. Alpha and beta anomers. D and L isomers. Depends on the spatial orientation of groups. Mirror images stereoisomers. Depending on the spatial orientation of the OH groups around the carbon atom, adjacent to the terminal primary alcohol carbon. OH group is 1 OH group is on the right, D isomer. OH group is on the left, L isomer. Optically have active isomers. Monosaccharides that rotate plane polarized light to the right are known as dextrorotary plus isomers, while those that rotate light to the left are levorotary minus isomers. Epimers. Carbohydrates isomers that differ in configuration around only one specific carbon atom, with the exception of carbonyl carbon. Example, glucose and galactose are C4 epimers. Glucose and mannose are C2 epimers. Galactose and mannose are only isomers, not epimers. Cyclization of monosaccharides. Most of the monosaccharides, more than 5 carbon atoms, are found in the ring form. Aldehyde or ketones react with the alcohol group of the same sugar to form the ring structure. Result is hemiacetal or hemiacetal respectively. If the ring has 5 members, furans. If the ring has 6 members, pyranos. Alpha and beta anomers. Cyclization results in formation of anomeric carbon at the C1 of an aldose and C2 in a ketose. Two cyclic isomers that differ only in their stereo arrangement about the anomeric carbon are called anomers. A anomer's hydroxyl group on the anomeric carbon is below the plane. Beta anomers. Beta anomer's hydroxyl group on the anomeric carbon is above the plane. Common monosaccharides, glucose. Metabolic fuel or glucose is also known as dextrose. Source, fruit juices, hydroxys of stretched cane or beet sugar. Common monosaccharides, galactose. Radially metabolized to glucose. Synthesized in the mammary gland for synthesis of lactose in milk. Constituent of glycolipids and glycoproteins in many cell membranes. Common monosaccharides, fructose. Readily metabolized sources, fruit juices, honey, pyrolysis of cane or beet sugar and inulin. Structure